Welcome to my video on solving two-step equations, special cases. So we've already looked at regular two-step equations. Now we're going to look at some special cases. So most of the time a two-step equation looks like this. So let's solve it. We have 2x plus 4 equals negative 12. So remember, we circle our number and variable, and we draw our t. What's the opposite of adding 4? Good, we subtract 4 from both sides. What happens to the 4? Good, it cancels and equals 0. So 2x equals, what's negative 12 minus 4? Good, negative 16. The opposite of multiplication is division, so we're going to divide both sides by 2. 2 divided by 2 is a 1 in disguise, so that cancels. And x will equal negative 16 divided by 2, negative 8. So x equals negative 8. Now to check it, you plug it back in, so we're going to write 2 times negative 8 plus 4 equals negative 12. 2 times negative 8 is negative 16 plus 4 equals negative 12. And what is negative 16 plus 4? Negative 12. So negative 12 equals negative 12. Now, if you want to be sure when you're double checking each step, use your calculator if you need to, if you're not real strong or confident in your integers. Because if you plug it back in correctly and truly check it, you cannot get any of these equations wrong. So that's a regular two-step. Occasionally, we might see something that looks like this. So I want you to be thinking. What do you think we want to get rid of first? And if you were thinking the 2, you are correct. We want to cancel out that 2 by multiplying both sides by 2. So we'll look at some examples in just a second. So the steps for solving special cases are as follows. It says use the multiplicative inverse property. So multiply by the reciprocal of the fraction. So if it's divided by 2, we're going to multiply both sides by 2. If it's divided by 8, we're going to multiply both sides by 8. Remember the blank rule of blank. So the golden rule of algebra. That means what you do to one side, you must do to the other. And then solve the remaining one-step equation. So number 1 says x minus 5 divided by 7 equals 8. So we want to get rid of that 7. The opposite of dividing by 7 is multiplying by 7. So we're using the multiplicative inverse property, because when this fraction's on the bottom, it's like saying 1/7. So 7 times 1/7 is just 1 in disguise. So we bring down our x minus 5. And 28 times 7 is 196. Now draw your t. The opposite of subtracting 5 is adding 5. What happens to the 5s? Remember, they cancel because when we have minus 5, that's like saying negative 5 plus 5, which equals 0. Additive inverse. And 196 plus 5 is 201. Okay, now to show the check, we have to do 201 minus 5 divided by 7 equals 28. Now, order of operations tells us to do the top first. So 201 minus 5 is 196. Divided by 7 equals 28. And then 196 divided by 7 is, of course, 28. So 28 equals 28. So it does, in fact, check. Now, remember, If I didn't say to show your check and you were just checking this in your calculator, you would have to type in 201 minus 5 and hit equals. Why? Because you want the calculator to do the top first. And if you want it to do the top first, then you have to hit equals. So 201 minus 5, hit equals, then hit divided by 7. If you forget to hit equals and then divide by 7, your calculator will not give you 28, and you'll think your answer is wrong when it truly is correct. So make sure you hit equals after you type in the top. Okay, let's look at example number 2. It says 15 plus n divided by negative 3 equals 6. So once again, it's a special case, so we're going to multiply both sides by negative 3, because that's the opposite of division. The negative 3's are going to cancel out, and we're left with 15 plus n equals negative 18. Draw your t. And what are we going to do to both sides? Good, subtract 15, because if I add 15, I get 30, and they don't cancel. But if I subtract 15 from both sides, 15 minus 15 is 0, so it does cancel. So n equals negative 18 minus 15 is negative 33. Now to check it, write down 15 plus negative 33 divided by negative 3 equals 6. Remember, do the top first, so the top equals negative 18 divided by negative 3. And what's a negative divided by a negative? A positive, so 6 equals 6. And it does, in fact, check. So that's how you solve and check this special case here. When we have a number plus or minus a number, a letter divided by another number. Okay, now we're going to look at a different set of special cases, so turn the page. And now we're going to be solving two-step equations and with a negative x. So we're going to have special cases with a negative x. So if there is no coefficient in front of the x, we see it as a blank in blank. Good. One in disguise. If there is no coefficient in front of the x and we see a negative sign in front of the x, we see it as a blank, blank, and blank. Negative 1 in disguise. Okay, let's look at some examples, and we're going to show the check for each one. So example 1 says 4 minus 1 times x equals 12. So circle your variable and anything in front of it, addition or subtraction. Now we want to cancel out 4, so would we add 4? Is 4 plus 4 0? No. Is 4 minus 4 0? Yes, so we want to subtract 4 so that the 4 disappears. So 4 minus 4 is 0. Bring down this, and when I bring this down, it's not positive 1x, it's negative 1x. Because remember, if I do KCC, subtracting a positive is the same as adding a negative. So because adding the negative is the same as this 1x represents negative 1x. What's 12 minus 4? 8. Now, the opposite of multiplication is division, so we can divide both sides by negative 1. Negative 1 divided by negative 1 is a 1 in disguise, so 8 divided by negative 1 is negative 8. So x equals negative 8. Now, to check it, we're going to plug it back in, so 4 minus 1 times negative 8 equals 12. What is 1 times negative 8? Because order of operations tells me to do multiplication first. Good, it's negative 8. So 4 minus negative 8 equals 12. And what is 4 minus negative 8? It's 12 because if I do KCC here, I get 12 equals 12. Now, when you're checking these, okay, if you're checking this in your calculator, okay, you don't have to show your KCC. You could just type in 4 minus -8 and hit equals, and you write 12 equals 12. Okay, I'm showing you how you would do it without a calculator here by doing the KCC, but a lot of the times you'll be double checking it in the calculator so you don't have to show the KCC. Okay, so number 2, 4 minus x equals 12. Now look, we have a minus in front of the x and there's no number, so what can I put in? A 1. So draw your t. How do I cancel out 4? Good. Subtract 4 from both sides. 4 minus 4 is 0. Bring down -1x, because remember the minus sign is there. What's 12 minus 4? 8. And what's the opposite of multiplication? Division. So I'm going to divide both sides by -1. -1 divided by -1 is a 1 in disguise. And 8 divided by -1 is -8. So once again, I got the same answer because it's really the same problem. I wanted to show you that these were the same problem. Now on the check, since I didn't originally have a 1 here, I'm just going to write 4 minus -8 equals 12. And this is what I was saying before. If you just type this in your calculator, 4 minus -8, and you get 12, you can just write 12 equals 12. You don't have to show the KCC unless you're figuring it out in your head. But remember, you always want to double check your integers in the calculator just so you don't get any of these wrong. Okay, moving down to number 3 and number 4. So let's do number 3 first. So once again, circle the variable and anything in front. And notice I'm going to stick a 1 there because there's no number. Draw your t. And how do I cancel out 12 negatives? Some of you might be thinking subtract 12. But if I subtract 12, I get -24. Does that cancel? No. So I'm going to add 12 to both sides. So what happens to the 12s? They cancel. Bring down the 1x, and I got to bring it down as -1x. 15 plus 12 is 27. And what's the opposite of multiplication? Good, division. So -1 divided by -1 is a 1 in disguise. And 27 divided by -1 is -27. So to check this, I plug it back in. So -12 minus -27, because remember, I put the 1 in there myself. It wasn't originally in there. Equals 15. Now, if I'm checking this in calculator, just type it in. And we would get 15 equals 15. So we know it checks. But don't assume you're always going to get 15, because if I had 27, positive 27, -27, that would be wrong if you truly checked it. So don't just assume it's always going to work. Type that in to double check. Okay, and the last one, circle and stick a 1 in there since I don't have a number. Draw t. And some people have asked, do I have to stick a 1 in there when it's positive or when it's adding 1x? And when it's adding just an x? And the answer is no. Because when you divide by 1, it doesn't change it. But when you divide anything by -1, it always changes the result. So that's the difference. That's why you have to stick a 1 only when it's negative or a minus in front. So what's the opposite of adding 15? Good, subtracting 15. 15 minus 15 is 0. Bring down the -1x. And 9 minus 15 is -6. The opposite of multiplication is division, so divide by -1. That slashes and a 1 in disguise, so x equals +6. So now, write down what we started with. So we started with -x, so -6 plus 15 equals 9. And what's -6 plus 15? Good, 9. So 9 equals 9. It does, in fact, check. Okay, that concludes our notes on special cases. I hope you have a great day.